This video is about working backwards, so it should be a review, and it's about how to solve an equation by working backwards. And this is going to be helpful when you have an expression that equals a number, as opposed to another expression. So building an equation and solving an equation are very closely related. If you know how to build an equation, you should know how to solve an equation. Because solving an equation is the inverse of building an equation. Just like getting undressed is the inverse of getting dressed. Unwrapping a present is the inverse of wrapping a present. Taking apart an IKEA table is the inverse of putting together an IKEA table. So when we're working backwards and trying to do the inverse, we need to remember to do inverse operations and in the opposite order. So for example, when you're getting dressed and undressed, well, when you're getting dressed, you need to put on socks before you put on shoes. When you get undressed, you have to take off your shoes before taking off your socks. So not only is taking off the inverse operation of putting on, but also we need to go in the opposite order. There's no way for you to take off the socks before taking off the shoes. Similarly, you need to put on your undies before you put on your pants. You need to take off your pants before you take off your undies. So with order of operations in math, we have a specific order that we need to use. The order of operations usually is referred to as PEMDAS, although there are other names, and of course we should know what those letters stand for. When we're solving an equation, we always need to go in the opposite order, the reverse order. So here's an example with a flowchart. Simon has $50 and earns $10 per day. When will he have $440? This is a pretty simple one, but let's just see what it looks like. So first you would need to build the function, and when you build the function, you would find that f of x, f of d, equals 50 plus 10d. So now you need to set up the equation. 50 plus 10d equals 440. Why 440? Because 50 plus 10d represents the total amount of money, and so does $440. That's the total amount of money we're looking for, so they have to be equal to each other. So now we need to solve the equation. Let's look at it. So here's the equation again, 50 plus 10d equals 440. So the question we need to ask is, what is being done to d when we were building that equation? You need to follow the order of operations. So we have d, and then what's being done to it in order to get to 10d? Well, we're multiplying d by 10. So we have d times 10, which is 10d. And then we had 50 plus 10d. How do we get that? Well, we need to add 50 to the 10d. So in order to build this function, we took d, multiplied by 10 to get 10d, and then added 50 to get 50 plus 10d. That's how we built that expression. But the equation tells us that 50 plus 10d is equal to 440. Those two things are equal to each other. So if we're looking for d, all we need to do is unwrap this number and unwrap that expression 50 plus 10d. In order to do that, we need to go in the opposite order and do the inverse operations. So the last thing that was done right here was plus 50. So we're going to have to undo that. In order to undo that, we have to subtract 50. So we subtract 50 from 440 and we get 390. What does that mean? That means that 10d is equal to 390. Because 10d plus 50 was equal to 440. So before we added 50, the 10d has to be 390. Why? Because 50 plus 390 equals 440. So that 10d has to equal 390, which is what we found here by undoing that plus 50. We undid it by subtracting 50. And we can go further back. And what was done at this step? Well, in order to get 10d, we multiplied d by 10. The inverse of times 10 is divided by 10. So we have 390 right now down here. We're dividing by 10, and we get 39. So that tells us that d equals 39. Great, that's our answer. We found what we were looking for, D, which is the number of days, so it will take 39 days for Simon to have $440. Here's another example. When we're looking at this pattern here, Jose built a function, g of x, to model the number of tiles in any figure. The question is, when will there be 651 tiles? You might, this is what I would do if I were you, pause the video right now and try to build the function yourself. See if you get the same thing that Jose got. And if you don't, is your function equivalent to Jose's function, which I haven't shown you yet, or is it wrong? So pause right now, build that function. Now that you have the function, compare it to Jose's function. So Jose's function, g of x, was equal to 2 times x plus 3 plus 5. And of course you can check to see if it works. Plug in 1, you get 2 times 1 plus 3, which is 2 times 4, which is 8, plus 5. 8 plus 5 is 13, and you should be able to see here that there are a total of 13. You could of course check all these other numbers and see if they work as well, and they do. So the question though says, when is g of x, which is the dependent variable, it is the number of tiles, when will that equal 651? So now we have g of x equaling this expression, and g of x equals 651, so we can set up the equation 651 equals 2 times x plus 3 plus 5. These two things have to be equal to each other because they're both equal to g of x. Great, so now we have an equation, time to solve it. We're going to solve using a flowchart. So we're trying to solve this equation, 651 equals 2 times x plus 3 plus 5. And the question is, what is being done to x? Again, we need to follow the order of operations. Well, we have parentheses there, so we know we're going to deal with that first. So we're starting with x. In the parentheses, what's being done to x? Well, we're adding 3 to x, which got us x plus 3. Then, what's being done after that? Well, the x plus 3 is being multiplied by 2, which got us 2 times x plus 3. Finally, what's being done to that? We're adding 5. Right here it says plus 5, so we're adding 5. That gives us 2 times x plus 3 plus 5. But what is that equal to according to this equation? It's equal to 651. So that's what we have. So now we need to start undoing all these operations by doing the inverse operations in the opposite order. So the last thing we did was plus 5. The inverse of plus 5 is minus 5. There we go. And that leaves us with 646, because 651 minus 5 is 646. Another way to think about that is, if this whole thing was 651, well then this part here, this 2 times x plus 3, has to be equal to 646. Why? Because 646 plus 5 is 651. So now we have this part, 2 times x plus 3, equaling 646. Now we need to undo this times 2. How do you do that? Divide by 2. And if you divide 646 by 2, you get 323. Another way to think of that is, if 2 times x plus 3 is equal to 646, that means x plus 3 has to equal 323, because 2 times 323 is equal to 646. So that means that x plus 3 has to equal 323. Over here we had plus 3. How do we undo that? Minus 3. And when we subtract 3, we get 320. Once again, another way to think about that. If x plus 3 is equal to 323, what does x have to be? X has to be 320, because 320 plus 3 equals 323. So we found that x equals 320. And there we go. So that means that figure 320 will have 651 tiles. So again, we went through kind of quickly, but it should have been review, and you can always pause, rewatch the video, do what you need to do to make sure you understand how to solve an equation when you have an expression equaling a number, such as here. Here's our expression equaling our number, 651. Working backwards Inverse operations in the opposite order will get you where you need to go. Using a flowchart can help make that easier.